If you're doing applied problems where y is a function of x, then presumably y and x both have units attached to them. In this video, we'll take a look at the units of the derivative. So let's say that y is a function of x. And you're taking the derivative like so. Then the units of the derivative are the units of y over the units of x. And this is especially easy to remember if you use Leibniz notation. Leibniz notation looks like a fraction, dy over dx, and its units are the units of the numerator, as it were, over the units of the denominator. Although I should probably stress that although I use the words numerator and denominator, this is not an actual fraction. It's a piece of notation that just looks like a fraction. So, for example, let's not put a formula up for this, but let's look at the following example. W of P, the average walking speed of pedestrians in a city measured, let us say, in feet per second, depends on the population of the city. Let's measure that in thousands of people. In general, the bigger the city, the faster people walk. And because walking speed is a function of the population, you could take the derivative of the walking speed in terms of the population. I haven't given us an actual formula to work with because the actual formula involves a logarithm and we don't know how to take those derivatives yet. But what we can do is talk about the units of this thing. The units are the units of the walking speed, feet per second, divided by the units of the population. Feet per second per 1,000 people.